Hello my dear students, welcome back to my channel Essential Academy Chemistry with Vinay. In this video, we are going to learn about a super trick box about Sn1 and Sn2 mechanism. In this, with the help of this trick box, children, you can solve any kind of questions that is based on Sn1 and Sn2 mechanism. I am 100% sure you don't get this all the four things that will fall on in the same box till now. This is the best trick box that I have here with you, so that with the help of this you can solve any kind of questions that is based on Sn1 and Sn2 mechanism. Here, if you observe in this trick box, on one side we have alkyl halide, nature of leaving group, nature of nucleophile, and nature of solvents. So in this video I will be just telling you about this trick box. In my next video I will be just telling you how we are going to use each of them and how to solve the different types of questions. We are going to have a very good practice session with us. Children, let us start with the first one. First one, we have alkyl halides. About this, I know very well that you already have a very good information that the tertiary alkyl halide, secondary and primary, this order is mainly preferable for Sn1 mechanism. The other one is primary, secondary, tertiary will be mainly prefers for Sn2 mechanism. Based on this alkyl halide, I am going to explain many of the main concept of alkyl halide and different number of examples also. Let us go for the next one, that is the nature of leaving group. Remember children, whenever there is an iodine, then that is going to leave very soon. It undergo very soon the nucleophilic substitution reaction. Then comes bromide, then comes chloride, and then comes fluorine. The next very important is about the nature of nucleophile. In the nature of nucleophile, children, you should know there are two types of nucleophiles. One is a weak nucleophile, the other one is a strong nucleophile. Always do remember, the weak nucleophile always prefers Sn1 mechanism. The examples are water, NH3 and amines. These are the weak nucleophiles. Whenever you see these reagents that is carrying out a nucleophilic substitution reaction, then it is always Sn1 mechanism. We'll go for the next one, that we have strong nucleophiles. The strong nucleophiles always prefer Sn2 mechanism, children. You can see some of the reagents which I have written here: KOH, NaOH, KNO2, KCN, AgCN, AgNO3, the most commonly asked ones, where they always prefer Sn2 mechanism, and these are the strong nucleophiles. Then we have the last, the most important one, that is the nature of solvents. In nature of solvents, there are two types of solvents that you need to know, that is polar protic solvents, polar aprotic solvents. The polar protic solvents, they always prefer for Sn1 mechanism, they support Sn1 mechanism. Here, an example for the polar protic solvents are water, alcohols, aqueous AgNO3, acetone with water. Children, this is a very important. When you see water as well as acetone, it is sure that it is going to be a polar protic solvent and it is going to go for Sn1 mechanism. Then we have polar aprotic solvents, which always prefers Sn2 mechanism. The example is dimethyl sulfamide. Then the other one is dimethyl formamide. So these are DMS, DMF and acetone. So these are the examples for polar aprotic solvents. They always go for Sn2 mechanism. In detail, we are going to solve many of the questions based on alkyl halides nature, based on the nature of leaving group, based on the strong and weak nucleophile, and also how the questions are going to be based on the nature of solvents. I hope it's very easy for you to recognize whether the given reaction is Sn1 or Sn2, whether it goes for Sn1 or Sn2. That's it in this video, children. Subscribe to my channel for more videos for the next upcoming video that I'll be completely explaining about all the four natures that is going to be helpful for you to recognize the Sn1 and Sn2 mechanism. Thank you. See you again.